Good evening all, and today we are going to cover AM GM inequality. Let's state it first for the simplest case. Let's say we have two positive number x and y. Then it tells x plus y over 2 is greater than or equal to root xy. Now this is very easy to prove algebraically because we can simply transport to another side and we can square the both sides. So that's gonna give me minus 4xy is greater than or equal to 0. So x square plus y square minus 2xy is greater than or equal to 0, which is equivalent to x minus y over whole square is greater than or equal to 0. And now very happily you can reverse this step. So I can start with this implies this, that implies this implies this. Now of being positive came in this step actually. Okay. Now of course for the equality case, x minus y square greater than or equal to 0 is definitely true for all reals x and y, right? It's not true for complex numbers, right? For example, I square is minus 1. So definitely I square is not greater than or equal to 0. Moreover, if I tell a square plus b square equals 0, what are the possible values of a? If a and b is real, then the only possibilities will be 0, 0. If a and b is complex number, then it can give many answers. For example, I square plus 1 square is also 0. So it can give multiple answers. Okay, so these are small things you must take into consideration. Anyway, so the equality case of this inequality will happen if x minus y equals 0 or x equals y. So to conclude, for two non-negative number x and y, x plus y over 2 is greater than or equal to root xy. And the equality will happen if either x equals y or at least one of them is 0. Since the second condition is obviously trivial, so basically we'll always mostly be concerned with strict positiveness, where equality will be achieved when x is equal to y. Now some of you might ask the general proof, like if I try to do it for three of them, let's say x, y, z divided by x and the power of this. And the equality case will be when all of these guys are equal. So this is as simple as this. I'll give you a proof of this in a very interesting way, which will not only enlighten the ideas, but also the method might help you to solve other problems. So let's consider a graph of a function y equal to ln x. You will soon get motivation of why I took this special function. One of the reasons is the domain of this function will be x is strictly greater than 0, which matches with our Guardian sub. Now let's say if I take 2 points p1, p2 with the coordinate x1, y1 and x2, y2. So what about the midpoint of this? It will be x1 plus x2 by 2, y1 plus y2 by 2. Right? Now from the very diagram, and we know the function is concave downward, because if I take any point, the line joining that point is below the curve, right? So the midpoint of this represents x1 plus x2 by 2, and the height is basically y1 plus y2 by 2. But corresponding to the input x1 plus x2 by 2, what is the height on the function? So that height will be ln of x1 plus x2 by 2. That's quite clear from the diagram. So there is a very small gapping, between the midpoint m and the corresponding height on the function p. So pm is definitely greater than 0. Okay, so what is this entire distance? The entire distance is ln x1 plus x2 over 2. That will be greater than or equal to, because pm can be greater than or equal to 0, will be equal to the midpoint output, which is y1, means ln x1 plus ln x2 over 2. Now this can be written as ln x1 plus x2 over 2 is greater than or equal to ln x1 x2, and by 2 from log property we can put on its head. Now since the base of ln is more than 1, hence the inequality follows. So this is a proof for the simplest case when we have two members. Now let's say if some of you ask, let's prove for 3 member. Of course you can do with centroid. So I can take a point p1, p2, p3. Geometrically I can join them. The centroid will have x coordinate sigma xi by 3 and y coordinate sigma yi by 3. So this distance of centroid from the x-axis is nothing but sigma yi by 3. But corresponding to the point sigma xi by 3, which is x coordinate, there exists a point on the curve. So corresponding to this point, if I'll move above on the curve, I'll get another point, let's say some m, and we have centroid G. So again, we know the distance of x-axis, let's call this point is O. So OM will be greater than OG in general. It can be even equal. I'm discussing the case where it will be equal. So again, OM value is nothing but ln of sigma xi over 3 will be greater than equal to sigma y by 3. Okay, so it's ln x1 plus ln x2 plus ln x3 by 3, and that is straightforward gives you sigma xi by 3 is greater than equal to product of xi to the power 1 by 3. Now, under what condition equality will hold? You know, for equality to be hold, mg must be equal to 0. Now, there are two situations in which mg can be 0. Either this curve becomes a straight line, because if curve becomes a straight line, clearly these two heights will be same, but that's not possible because we have log curve. So curve cannot change its identity. So the other choice is obvious when all the 3 points becomes the same points. Okay, so the distinctive identity is lost. So of course, when all these inputs are equal, because when all these points slides and accumulate exactly on the same location, okay, whether you tell y coordinate of centroid or the height of the function, that's going to be the same. Still, the challenge is how we are going to prove it for a general case, let's say endpoint. Now that's also not so hard. So let me do it for 4 points now. Unfortunately, you don't have a very decent method of visualization 4 points like centroid. Okay, so here we'll play a trick. Given any 2 points on the curve, definitely there exists a point, let's say A, which divides this into 1:1. So what will be coordinate of 1? x1 plus x2 by 2 and y1 plus y2 by 2. Now I'll take point A and we'll join this with other point P3. Now again, I'll take a point on this line such that it divides this into 1:2. So now we have point B which divides AP3 into 1:2 ratio. So what will be the coordinate of point B? Yes, you can clearly see it's 2 times of x1 plus x2 by 2 plus 1 times of x3 coordinate by 2 plus 1. So it will become x1 plus x2 plus x3 by 3. And similarly y1. Now again, with this new point as the new coordinate, I'll join with P4. And now I'll again select a point which divides into 1:3. So that will give the location of this point as sigma xi by 4 and sigma yi by 4. You can keep on repeating this process. Let's say if I take P5, now again select a new point and divide it into 1:4 ratio. If you have P6, you take again a new point, divide into 1:5 ratio. So for every new point Pn, we are dividing the line joining the previous one into 1:n minus 1 ratio. So by doing this again and again repetitively, the final point for Pnth point will get a point which is definitely below this curve, right? So what will be the x coordinate of that? It is sigma xi by n. Right? Corresponding to this x coordinate, the height of the function will be ln of sigma xi by n. And what is going to be the y coordinate is sigma yi by n. So again, this height, the height of the function will be more or equal to the x coordinate, the y coordinate of the point. And that proves the identity very logically and nicely. I hope you have enjoyed the proof. This proof is known as Jensen's inequality. Okay, so we have done the proof using calculus, but we using very fundamental ideas. Even if you are not aware of calculus, still you can do this. Okay, so far so good, and we have understood the only case in which if the curve is intact, so equality will happen when all these points become same point. Let's do some of the application of AM GM inequality. So one of the most easiest application and most important is a number and its reciprocal is always more than equal to 2 for x greater than 0. We can't put x equals 0 because in that case it will be not defined. So this is a straight away application of AM GM. We can apply AM GM on x and 1 by x. So that by 2 will be product of those two objects. and that straightforward gives you 2 because this will be 1 and you are done, right? Okay, now the question is, can we apply x plus 1 by x? Can you prove this will be less than equals -2 for x less than 0 using AMGM? It feels no because x is a negative number, but here we can play a trick. So x equals, if I keep minus y where y is positive, I have full x now, okay? So since y is positive, so I can apply AMGM on y stuff. So now I'll put minus y minus 1 by y is less than equals -2, which is equivalent to proving this, and this we have already proved for any positive number, right? So here equality will happen at x equals -1. In the above case, for equality, these two guys should be equal because on x and 1 by x we have applied. So x square equals 1 implies x equals plus -1. Of course x was positive, so -1 will be discarded, right? So we know it will get n equal to 2, and this is the minimum value because I can attain any value more than 2 this side. Now suppose if I solve it in this way, you have to track me and you have to catch me where is the mistake, right? So let's say x I'm writing as x over 3 plus 2x over 3. Of course I can write. And 1 by x, let me write 1 by 2x by 1 by 2x. So now instead of x and 1 by x, I'll apply on these 4 quantity x by 3, 2x by 3, 1 by 2x, 1 by 2x. So these are 4 chunks, 4 objects that I am having, and now let's apply AMGM over here. So what is the aim? Sum of all by 4, 4th root of their product. So which gives me x plus 1 by x over 4 is greater than equals 4th root of x gets cancelled. We have 2 is getting cancelled, so 1 by 18 implies x plus 1 by x is greater than equal to 4 times 4th root of 1 by 18. Now clearly this answer is not true. If you calculate this, this quantity comes out to be 1.9419. You can use your calculator. So from here what answer we are getting is x plus 1 by x is more than equal to 1.9419 approximately. So in that sense even this is correct because it's telling this value is definitely more than 1.9419. So 2 is definitely a possible answer. So from the first approach what I am getting, x plus 1 by value will be either 2 or more than 2. From the second one what I am getting, it will be either 1.9419 approximately or more than this. Now which answer is proper answer? So of course one of them is wrong, right? In fact, now we have to check whether the equality in this case can we attain this value or not. Okay, so that's a challenging question. See, it's very beautifully decorated because I intentionally selected the objects in such a fashion. For equality, these 4 objects must be equal for AM GM inequality. So of course 1 by 2x is equal to 1 by 2x, but what about the first 2 guy? X by 3 equals 2x by 3. For equality case, like to attain the value of 1.9419, we must have a value of x which makes all these 4 objects equal. Now that is impossible. Why? Because although these 2 sides are equal, here x will get cancelled and we'll have 1 equals 2. That's a contradiction. It means this equality cannot be achieved. So what we got is just x plus 1 by x. From this manipulation we can tell it will be more than this value. Is that a wrong answer? In the strict sense, obviously it's not the exhaustive step because any value between 1.91 to infinity cannot be achieved because all these value is not achievable. So what you are getting is a very conservative kind of window from here. Okay, so whenever equality case you are not able to get by somehow, please make sure like there will be inconsistency in your boundary condition. Okay, that's why we will not resort to this process. In fact, it's simply telling like you are in India, but it's not telling like you are in Bangalore. Okay, the first one is giving you a specific GPS location. Second one is just a superset of that. Okay, so again, I'm warning you, the answer that we got is not wrong, but in fact it's a superset. So there were many elements in the answer which was not exhaustive. For example, there was many elements which can never be attained. Okay, and that's a very misconception or wrong application of AM GM inequality. For x belonging to 0 to 1. Now clearly for x belonging to 0 to 1, these two quantity is going to be non-negative. Now the point is not to just tell you the solutions but also the thought process. Now one of the obvious method will be calculus, where you take y equals x into 1 minus x cube, find derivative, make it 0, find the critical points and find the answers. Let's see how we can apply MGM. Now obviously if I'll take, let's say, object x and 1 minus x cube, which might be my first thought process, if I apply AMGM on both these chunks, RHS is not going to be constant. We have x and 1 minus x cube. Now we need to manipulate. Okay, so instead of using these two terms, I have to come with more terms so that maybe their summation is constant, because we want for product their maximum values. So how to manipulate this? Okay, let's start playing the game. Maybe I can think of bringing 3x into picture so that it kills this. So maybe xy3, 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 and rest is 1 minus x cube. Now clearly you can see even if you add them, it's not going to be constant. Okay, and moreover product will give x cube into 1 minus x cube. It's not x into 1 minus x cube. So this is our wrong choice. What about other thought process? Okay, so if x cube is there, it's better if I can directly bring x cube into picture. Right? Now unfortunately from x, how will you bring x cube? So the only possibility is x cube by x squared. So that's clearly not a good choice, right? We need sum of elements to be constant. So what else we can do? Okay, so 1 minus x cube is begging for x cube kind of term instead of x, right? Now again, if I take x cube and 1 minus x cube, their addition will be 1. So the answer that I'll get using AM GM inequality is x cube minus 1 minus x cube maximum minimum values, right? So that's still not a good choice, because we want x times 1 minus x cube value. It means this should appear once, but x should appear, not x cube. Okay, what if I take x cube, x cube, x cube, and 1 minus x cube? Well, if you do so, what we are gaining? Nothing much, because again if you add this, it will not be constant, so that's still gone. Okay, so but now we have at least some hint, because if I take 3 objects, 3 copy of x cube and just 1 copy of 3 into 1 minus x cube, this was because they will add to 3x cube and I want 3x cube to be killed. So in total I have 4 objects, such that let's apply AMGM on x cube, x cube, x cube, and 3 into 1 minus x cube. So Ram, Syam, Mohan, Manmohan divided by 4 is greater than or equal to 4th root of Ram, Syam, Mohan, and Manmohan. And clearly LHS is 3 over 4 is greater than or equal to 4th root of, we have x ka power 9 to 1 minus x. These values. Okay, so what about this value? Now again we can see like x ka power 9 cannot give birth to x, right? Because it will be x ka power 9 by 4, 1 minus x cube to the power 1 by 4. So again we are trapped. We got an answer for a wrong question. Okay, and here is our last attempt. So now at least we know, okay, so we want here x cube such that when it gets gelled out, it should produce x. And 1 minus x cube, when it is gelled out, it should produce 1 minus x cube. Okay, so that gives me a hint of getting maybe x cube over here and 1 minus x cube to the power maybe 3 over here. That might work. Okay, so this time let's apply AMGM on the number 3x cube, 1 minus x cube, 1 minus x cube, and 1 minus x cube. Let's see what happens. So again, with the similar notion, this sum is going to be constant. It's greater than 4th root of their product, so 3x cube to 1 minus x cube to the power 3. And now we are lucky perhaps. So we have 3 by 4 to the power 4 is greater than equals 3x cube into 1 minus x cube. And this is nothing but 3 times x into 1 minus x cube whole cube. And that gives the answer, because 3 by 4 to the power 4 by 3 is greater than is third root x into 1 minus x cube. And this is the max value of this expression. At what point equality will come? Of course, equality will come when these guys are equal. So since 1 minus x cube is already equals 1 minus x cube, that will not reveal any secret. And x equals 3x cube. So by comparing this, we have x equals 1 by 4th root of 3. So you see, it was a very interesting question. Moreover, the approach was enlightening. Now, of course, in the examination hall, you will not start manipulating this way. So once you gain practice, it's easy to manipulate with AM GM inequality, because 1 minus x cube was begging for, like x cube kind of a structure. And that's why we attempted to give x cube and 1 minus x cube. Now again, if I'll add it, directly we'll get x cube 1 minus x cube. So hence we come with 3 copy of this, just 1 copy of 3x cube and 3 copy of 1 minus x cube. We have to find the maximum value of xy, 72 minus 3x minus 4y. So max of this, if xy is strictly positive and 3x plus 4y is less than 72. So basically question I've taken from the geometry, where 3x plus 4y less than 72 will represent. So we have a line, and less than 72 is this region. Okay. So now you pick up any point in this region. And for any point in this region, there will be a value for this value. Let's say if I take origin 0, 0. Okay, so for 0, 0, there will be the value of this expression, that is just 0. So every point will have a status associated to this, a number associated to this in this plane. Okay, out of all that, you have to find the maximum of this. Now some of you might feel, sir, this will happen, of course, when the point is too far, maybe minus infinity or infinity. But you see, there is a tug of war, because all the minus infinity, comma infinity might satisfy this relation. But when one is growing, other is again decreasing. So tug of war. So this might be balanced. Clear? So let's try to solve this. And here is a hint. Hint is coming strictly from this boundary condition. So all hint of AM GM inequality will come from the restrictions on the object. Since xy is positive and 3x plus 4y minus 72 is also positive. Okay. And since 72 minus 3x minus 4y is also positive, so it's a clear case of AM GM inequality, because x, y and this quantity they have given non-negative. Now if again someone blindly applies on x, y and 72 minus 3x minus 4y, there is no hope, because they will not add to be constant, right? So what is the idea? Yes, this time is quite clear, because for 3x we have to bring 3x into picture, for y we have to bring 4y into picture. By the way, in the first problem, I hope you have already understood. So instead of applying on x, y and 72 minus this, we attempted to apply on 3x, 4y and 72 minus this. And that will simply give me AM of these three numbers divided by 3 is greater than equals GM of them. So 3x into 4y 72 minus 3x minus 4y. And this quantity now simply it's 24 is greater than equals root over 12 times xy 72 minus 3x minus 4y. Hence this was our question. Let's call it Q. So 24, and of course it's cube root of that. It's 24 cube by 12 then equals Q. So Q max is 24 cube by 12, which will come out to be 1152. Now again, at what point equality will come? So for the equality, these three guys must be equal, and that will give a value of 9x equals 72 or x equals 8. So 3x must be equals 4y and must be equal to 72. Okay, so we'll get the value of x equals 8 and y equals 6. where is x equals 8, y equals 6, it will be in first quadrant somewhere, 8, 6. Is this on the line? Is this on the line? It's 24, 24 is 48, no. 8, 6 is not on the border line. Okay, so this is the special point. This is the special point for which we'll get the maximum value. Now those of you who are wondering, like, is there a direct geometrical method of doing this? Of course it's yes, because this represents, like for a particular value of y, you can plot these curves, and if you